Integrated Math 3. So these are the solutions to the test review. All of the test problems are exactly like these, except numbers have been changed. So you might want to go ahead and do this alongside of the test. Do them both at the same time. Okay, so number 1 says, what rule function does the table below represent? Well, I restated this question on the test to say, write the equation for these data points in the form of a b raised to the x power equals y. So you have to determine the values of a and b. Okay, so to do that, you first use the 0, and then you use the 1. So you're going to plug the 0 in for x so that it gives you -3 for y. Okay, so this is the x over here, this is the y. So we're going to do that. So AB, so we're going to say AB to the 0 power, whatever x is, we're going to put 0 there. That means that y should equal -3. Okay, so b to the 0, any number to the 0 equals 1. So that's going to be a times 1 equals -3. And if a times 1 equals -3, then a must equal -3. So now we figured out the value for a, now we need to figure out the value for b, and we can use this value that we just figured out to do that. So we're going to rewrite this equation, so a now equals -3, b, and now we're going to use 1 and -15. So b to the first equals -15y. So when x is 1, y is going to be -15. Okay, so b to the first just equals b, so it's -3b equals -15. You divide both sides by -3. Okay, these cancel, so you end up with b equals -15 divided by -3. The negatives cancel out, so it's 15 divided by 3 is 5. Okay, so what that means then is that a is -3, b is 5, raised to the x power is going to give you y. That's your final answer, and you can check that. Just use one of the other data points here. So let's use 2. So 5 squared is 25. 25 times -3 is -75 for y, and 2 does give you -75. Okay, so you can do the same, plug in 3 for x, and see if when you compute it, it gives you y equals -375, and it will. So that's the answer there. Okay, down here. Without graphing, identify the domain and the range. Okay, so domain are possible values of x, and range are the possible values of y. Alright, so if you look at this, x can take on pretty much anything, but what we do, the way we do this is, rather than just guess at it, you go ahead and make a t-table. So here's the value of x, and you get to pick those. That's the independent variable. This is the value of y you're going to come out with, and I always like this middle space for the function. So the function is just this up here. 2 1/4 raised to the x minus 3. Okay, and then the numbers I like to use are -2, -1, 0, 1, and 2. And then I'd like to leave space below the 2 and above the -2 for some additional values I might want to use, and you'll see what I mean in a minute, okay? All right, so let's go ahead and plug this in. So this is going to be 2 times 1/4 raised to the -2 power minus 3. Okay, you may have to do this off on a piece of scratch paper. You don't have to show all your work for this kind of calculation. So that, in a sense, you should show your work on everything, but you don't have to show basic math calculations. So remember what a negative exponent does. A negative exponent flips. It takes the reciprocal of this number. So you're going to flip this over from 1/4 to 4, 4 over 1. and then you're going to square it. That turns it into a positive number, so it's raised to the second power. So this is equal to 4 raised to the positive second power. That equals 4 times 4, which equals 16. 16 times 2 is 32. 32 minus 3 is 29. Now we'll do it for -1. So again, the negative is going to flip this from 1/4 to 4 over 1, or 4, and 4 to the first power is just 4. 4 times 2 is 8, and 8 minus 3 is 5. Okay, anything raised to the 0 power is 1, so 1/4 to the 0 is 1. 1 times 2 is 2. 2 minus 3 is -1. Okay, 1/4 to the first power is 1/4. 2 times 1/4 is 2/4, and you reduce that to 1/2. 1/2 minus 3, you might have to go off to the side and calculate that. Let's just do that. 1 over 2 minus 3. So what you're going to have to do is have a common denominator of 2. So you're going to have to multiply top and bottom by 2. And first you turn that into a fraction. 3 becomes 3 over 1. So what that then becomes is 1/2 minus 6 over 2, which equals 1 minus 6 is negative, equals 1 minus 6 is -5 over 2. And that's -2.5. So I'm going to write it over here as -2 and 1/2. Okay, and finally this one we have 2 1/4 raised to the second power minus 3. Okay, so 1/4 squared, you square the 1, that's 1. You square the 4, that's 16, so it's 1 over 16. So 2 times 1 over 16 is 2 over 16, that's 1/8. 1/8 minus 3 is negative. You can do it the same way you did here, is -2 and 7/8. Okay, so the domain, these numbers, can go all the way to -infinity in this direction, 0, -1, -2, -10, -1,000,000, -infinity. And in this direction, they can go 0, 1, 2, 10, 1,000,000, infinity. So the range for x is -infinity is less than x, which is less than positive infinity. So they can go from x all the way down to -infinity, and then go from x all the way up to positive infinity. Over here, it's not quite as obvious. It looks like in this direction, we start here and we go in this direction, it looks like the numbers are going to get bigger and bigger and bigger forever. In this direction, it looks like they're going -1, -2.5, -2 and 7/8. It looks like they're kind of not getting more and more and more negative. They're just kind of staying right around this general area. And if I were to look at that, I would guess that's heading towards -3. But let's try it out. Here's how you can do that. You do pick a fairly big negative number, or positive number. So 1, 2, I'm going to pick 10. So 1/4 to the 10th power So 1/4 to the 10th power equals, 1/4 is 0.25. If you don't know that, you just divide 1 by 4. 1 divided by 4 gives you 0.25. And I'm going to raise that to the 10th power. And that gives me a 0.000000954. Now I'm going to multiply that by 2. And that gives me still a really negative number. And now I'm going to subtract 3. So I should write it out here. 2. This is 1/4. And we're raising that to the 10th power, and then we're subtracting 3. And when I subtract 3, I get -2.9999, -2.999. It just keeps going. So you can see this number is really tending towards -3. Okay, that's very, very close to -3. It's never going to go beyond -3. So the range is going to be, so there's the domain, the range is going to be from from -3. because that's as negative as it's going to get, is less than y, which is less than, and in this direction, it's getting more and more and more positive. If I put a 10 up here, that would be 2 to the 1/4 raised to the raised to the 10th power. It should, sorry, that should be negative 10. So I want to do that. Raised to the negative 10th power. Minus 3. So the negative is going to flip this over, so instead of 1/4, it's going to be 4. 4 to the 10th power is some huge number. I'm not even going to do it on my calculator. So 4 to the 10th power is a huge number. So this is just, I'm just going to write toward infinity. Because as this number, as you go more and more negative in this direction, negative 1,000,000, negative 10 billion, whatever, this is going to become more and more towards positive infinity. So that's going to be an infinity there. And so there's your answers right there. That's your answer for domain. That's your answer for range, okay? You just have to do it by plotting it out. Again, I would start with -2, -1, 0, 1, 2. See if you can see what the trend is going to be, and if you can't, then below the 2, pick a number that's a bit bigger than 2, like a 10, and from the -2, pick a number that's a bit more negative than -2, like -10, okay? All right, so that's how you do that. Okay, to do the next problem, let me show you what it is. Okay, it's this one, and it says, without graphing, describe. So that means in words, and on the test I put in words, the transformation f of x to g of x. So how do you get from here to here? So what they're doing is they're saying 4 to the x power. Here they're saying 4 to the x minus 1. So how does that change it? And then they're not adding any number over here, but here they're adding a 2. So how does that change it? So we're just going to go ahead and put both of those functions onto Desmos. So we go into Desmos. There is Desmos, graphing calculator. Okay, so the first thing I'm going to put up is 4. What you need to do is pull out this keyboard down here on the bottom, and I'm going to put 4 and then a to the b power. It just puts you up in the exponent x. Okay, so there's 4x. Now I'm going to hit enter and go down to the next line, and I'm going to put in the g of x function. So that's going to be 4, and then it's a to the b, and it's going to be x. You need to put that in parentheses. So parenthesis x minus 1. Close the parenthesis, and now just hit the arrow, the right arrow, it goes down again, and then it's plus 2. And that's the second function. So let's take it one at a time, okay? Let's take off the plus 2. So to go from 4 to the x to 4 to the x minus 1 is it shifted the function to the right by 1. Okay, so if you look down here, you want to find a place where it crosses the grid lines. Let me zoom in a little there. See, it crosses the grid lines right here at x equals 0, and then the blue one crosses the grid lines at x equals 1. So this red graph got shifted to the right to create the blue graph. So what you can do is say that you shift. I'm going to write this down, although you can't see it. 1 right, and this is all you'll need to do for the answer for me. Now let's see what the other thing does. Let's go back and just make it 4 to the x, but now we're going to put the plus 2 in. So we're doing the two of them separately. Okay, and I'm going to zoom out. Okay, and what you can see is this one's easier. You can see that the line is pretty much right on the x-axis, and this line is right on the axis y equals 2. So it shifted the graph up 2 positions. So that plus 2 shift up. So you shift up. Shift 2 up is the way I'll write it. Okay? And of course, if you put them both together, you can do that, but you don't really need to do it. You just do them one at a time like that, and that's what it looks like, okay? So Okay, so that's all you would have to write for this answer, okay? That it shifts 1 to the right. That's this up here in the exponent. The x minus 1 shifts it 1 to the right. And you can put an arrow if you want. And the 2 here shifts it 2 up. And that's it. That's all you need to write for that. Okay, let's keep going. All right, so we have 256 to the x power equals 4. For this one, you can use a common base. 256 is a multiple of 4. It's 4 to the 4th power. So the way you could do this one is 4 raised to the 4th power. Okay, that's what 256 is. And then you have that x up there, so you can put it out here. So this is 256. That's the x. So that's that. Now the 4 is simply 4 to the 1st power. That's 4 to the 1st power. So now what you do with these two, okay, so you have 4 raised to the 4th and then raised again to the x. So that's like rule number 4, a raised to the x and then raised to the y. You multiply those two together. So this becomes 4 to the 4x, and over here it's still just 4 to the 1. Well, if 4 raised to this equals 4 raised to this, then these two exponents have to be equal to each other. So 4x equals 1. Divide both sides by 4. These cancel, and you end up with x equals 1/4. And that's your answer. Okay. What if you didn't recognize that 256 is a multiple of 4? This is called the common base method. You could have simply taken a log. You can do this. Log 256x. And anything you do to one side, you do to the other. Log of 4. Okay? Now, rule number 12 tells us that if you have log of a base raised to a power, you can take that exponent and bring it out front. So like right there. Just take that and bring it out into the front like that. So what that means is this x can come out here and become x log 256 equals log 4. So now you can go, and I'm going to do on this the handheld calculator. If you don't know how to use either the online calculator or the Desmos, get in touch with me during office hours, okay? So this is log of 256. I can put that in parentheses if I want. So log 256, and that's going to equal 2.41. So it's x times 2.41. And log of 4 here is just going to be log of 4, close the parentheses, and that's 0.602. Okay, so I'm going to divide both sides by 2.41. Those cancel, and I'll come over here. 0.602 divided by 2.41. And that gives us, if I round it, is x equals 0.25, which 0.25 is the decimal form of 1/4. So you get the same answer either way. And either of these would be acceptable if you left the answer in either of those forms, okay? So if you didn't want to use the common base, you can just make logs out of both of them. That's how you always get a variable out of an exponent, is by taking the log, and then that will do that. Okay, let's move on to number 5. So 5 and 16, there's no common base there. No multiple of 5 gives you 16. One's an odd number, one's an even number, so you know you're not going to get that. So you're going to go ahead and use this method here. Okay, so we have log. Anything you do to one side, you do to the other. Again, we'll put that in parentheses. You bring that out in front. Okay, so now I can just figure out what the log of 5 is and the log of 16. I can compute those on the calculator. So log 5, close parenthesis, gives me 0.699. And log of 16, log 16, and that is 1.204. Alright, so now I'm going to divide both sides by this. Cancel that. Okay, and you get x plus 2 equals this divided by that, so that gives us 1.72. Okay, subtract 2 from both sides. Okay, and over here these cancel and you end up with x. X equals 1.72 minus 2 is 277. And that is a negative. So that's the answer. Let's check that answer up here. If we plug 0.277 in for x, we should get this would give you 16. So let's do that. So 0.277, that's a negative 0.277. I'm doing it off screen. Negative 0.277 plus 2 equals 1.723. 5 raised to the 1.723 equals 16. Okay, so that is the correct answer. So again, you take that, plug it in there. Negative 0.277 plus 2 gives you 1.72. 5 raised to the 1.72 gives you 16. Again, you don't have to do that. It's just a way of checking your work. All right, let's keep going. Number 6. Okay, so you're solving. That means there's actually a specific answer that you're going to get for this, okay? All right, so when you do that, the first thing you do is you condense these, all right? And the way you do that is you use rule number 10. Rule number 10 says log of A plus log of B equals log of A times B. So we're going to condense those. Log base 4 is this times this. Okay, so that's the first step here is condense. You turn it from 2 logs, you see the word log twice there, to just once there. That's called condense. Okay, the next thing you have to do is you got a variable stuck inside of a log right there, and we use the inverse for that. All right, so now we're going to come down here and do the inverse. Okay, what does that say? That says if you have a variable stuck inside of a log, if you take that log of that variable and make that the exponent of 10, like that, you'll get the variable out. The log and the 10 will cancel out. You end up with just the x. And you don't really have to understand why that works. It just does. So we're going to take everything here. We're going to raise the left side to 10 to this power. Whoops, I take that back. It's a 10 if it's a log base 10. Sorry, I think it's going a little too fast here. This is a log base 4, so that means what you have to make this an exponent of is 4. This is a base, and this is a base. If they're going to reverse each other, they have to be the same base. So I'm going to raise this log base 4 of this. And I'm going to go ahead and distribute this. 8 times x is 8x, and 8 times 5 is 40. So I just went ahead and did that step. Okay, now that's going to equal 4. I took this and made it an exponent of 4, so I have to take this and make it an exponent of 4, like that. Okay, so both sides become an exponent of the number 4, and the reason I chose 4 is because this log is in base 4. So now I'm going to come back up here, and so these two cancel out. 4 and log 4 cancel out, so this simply comes out by itself. So it becomes 8x plus 40 equals 4 to the first power is 4. Okay, now it's just algebra problem. I'm going to subtract 40 from both sides. This cancels. This becomes 8x. And this becomes 4 minus 40 is negative 36. Now I'm going to divide both sides by 8. These cancel. 36 divided by 8, if you do that on the calculator, you're going to get this. Negative 4.5. Okay? And that's your final answer. All right, here we go. Solve logarithm. Be sure that value. Oh, anyway, it gives you a lot of stuff to do here. So, okay, so let's go ahead and solve this. So again, we're going to condense it first. So when it's a negative sign, it's log A minus log B equals log of A over B. So that's what we're going to do on this side. So we're going to turn this into log base 9 of this over this. Okay, that becomes that. And then the other side for right now stays the same, log base 9 of 12. Okay, well, first of all, let's figure out what this is. You have two very specific numbers there, so you can figure out an actual number for this. But our calculator doesn't do base 9, so what we have to do is use the change of base. So log of x, y equals log of any base you want to choose, and we choose 10, of y over log of that same base, 10 of x. Okay, so this is going to become, just going to go over here and do this over on the side. So this is going to become log base 10. You don't have to write the 10 there because it's implied. If you don't write any base, they assume it's 10 of 12. But I just want to emphasize that you get to choose that base. And this one is log base 10 of 9, the smaller of the two numbers. Okay, that one's the base. Okay, so now you do this on your calculator, and it's just very simply the log on your calculator is in base 10, so it's just simply log 12, close the parenthesis, and you get 1.079. Okay, and down below is base 10 log 9, so log base 10 9, close the parenthesis, and it's 0.954. And if I divide that by that, I get 1.13. So this equals 1.13. So now I can come back to my main equation here down here, and I'll just write that out. So log base 9 okay. At this point, we can do the same thing that we did up above, up here in this previous problem. We're going to raise that to the 9th power. I'll go ahead and just put these all in the same parentheses. I can do that. Okay, so again, base 9 here and base 9 there inside the log, they cancel out. Those two cancel out, so you just end up with this. And now I can go to my calculator and do that. 9 raised to the 1.13 power, so that's 9 caret 1.13, and that's 11.98. Okay, now it's just algebra. I'm going to multiply both sides by x. These two cancel out. So now I have x plus 6 equals 11.98. X, 6, subtract x from both sides. So this goes away, and you have over here, you have 6 equals 11.98 minus x is 10.98. X. Now you divide both sides by 10.98 x, just by 10.98, excuse me, just by 10.98, so that cancels with that, so you just have x left. So you subtract, you divide this side by 10.98. Divide by 10.98, yes. Okay, and that leaves us with x. I'm going to move the x over here, equals 6 divided by 10.98 equals and that is your answer. Okay? And so the final answer is x equals 0.546. All right? So again, you have to use a change of base to figure out what this is, and it's 1.13, what this is right here. And then you condense these two to become this. Now that you've done all that, you have a base 9 there. So the way to get a variable outside of a log is you raise it to that base. So it's 9 raised to this power. And then you have to do the same thing the other side, 9 raised to that power. So these two cancel out. You just end up with x plus 6 over x. And that number turns out to be 11.98. And now it's an algebra problem. You multiply both sides by x. These two cancel out. You have x plus 6 equals 11.98x. Now you subtract x from both sides. And over here you just have a 6 left on this side. And over here you have 11.98 minus 1 is 10.98x. Divide both sides by 10.98. And that's 6 divided by 10.98. And that gives you x equals 0.546. So that's the answer for that. All right, number 6. Okay, this is another common base problem. By the way, I did problems, a couple things. I did problems 11 and 12 before I did these, okay? So keep in mind they're a little out of order on the video, okay? But you can just adjust for that. And so let's go ahead and do number 6 now. So there's a common base here. So 4 times 4 is 16, and 4 times 4 times 4 is 64. Again, if you didn't recognize that, you can just put a log there, bring the exponents out in front and do it that way. But I'm going to do it the common base method. So 16 is equal to 4 squared. So I'm going to put that in parentheses, and that simply equals 16. You still have the 3x plus 2 out there, so you have to write that. Now that equals 64. That equals 4 to the third. Put that in parentheses, so that equals 64. And then you have x minus 2 out here. Okay, and rule number 4 says a to the x raised to the y is going to be a to the x times y. So this times this. So what is this times this? If you put it in parentheses like that, it's 2 times 3x. So it's 4 to the 2 times 3 is 6x. And 2 times 2 is 4. So 6x plus 4. Okay, that equals over here 3 times x is 3x, and 3 times negative 2 is negative 6. So 4 raised to this equals 4 raised to this, then these two exponents have to be equal to each other. So 6x plus 4 equals 3x minus 6. Okay, I'm going to come over here and do the algebra. It's just an algebra problem right now. So 6x plus 4 equals, what is that? 3x minus 6. Okay. All right. Okay, get all the x's on one side, so I'm going to subtract 3x here, 3x here. These go away, and this over here comes 6x minus 3x is 3x plus 4. And over on this side, that went away, so you have negative 6 equals. Okay, now we're going to subtract 4 from both sides. Okay, these go away, so you end up with 3x on this side, and negative 6 minus 4 is negative 10. All right, divide both sides by 3. These cancel, and you end up with x equals negative 3. If you do it on your calculator, 10 divided by 3 is 3.33, negative And that's your final answer right there. Okay, so again, use common base, or you could have done this, put logs out in front of this, and then done this, 3x plus 2 times log of 16 equals, bring that out in front, x minus 2 times log of 64. Okay, that's an alternate way. But problem number 6 on the test is going to be a common base situation like that. Okay, just have to figure out what that common base is. In this case, it was 4. On the test, it'll be something different. Okay, let's keep going. We are now up to number 7, and it's telling you to expand. That's the key. Okay, and notice it's not an equation, it's an expression. Okay, that they use that word. That means it doesn't have an equal sign, so you can't actually solve for x and y. You can just expand it. So that means you want the word log to appear more times. So this principle, you have two things divided. So that's going to be rule number 11, that if log of two things divided is going to be log of A minus log of B. Log of what's on top minus log of what's on bottom. That's rule number 11. So we're simply going to say this. What's on top minus okay. There's all kinds of things you can do with the log base 3 and the 81. You can do something with that. You can do something with that. I am going to keep life simple for you. Just leave that as the final answer. You don't have to go any further than that, okay? Because I don't want you to have to guess what am I expecting you to do. For example, log base 3 of 81 equals 4. So if I could just take this and separate it from the x squared, which I can, that would become the number 4. I'm not going to go there. Let's just leave it like that. One-step problem, you're done. Okay? Okay, this is a condense. So that means we have log appearing 3 times. We want it to appear only once. So the first thing we're going to do is we're going to take these coefficients out in front and turn them into exponents. We're going to do the opposite of what we've done in previous problems. So this becomes log base 2 of x plus 1, and then this goes up and becomes an exponent to the 1/2 power. Same thing here. Plus log base 2 of x, and this 3 goes up and becomes an exponent of x. It goes up to there. Okay? And then this is minus log base 2 x minus 1, and that 2 goes up and becomes an exponent, so it goes up there like that. Okay? Now we simply use rules number 10 and 11, the log A plus log B and the log A minus log B. Here you have a log A plus log B. So these two are going to be on the top, and then minus this is going to be on the bottom. So your final answer is going to look like this. Okay, and that's your final answer. Okay, plus puts these two multiplied on the top. The minus makes that a division down there on the bottom, and that's your final answer. 2 steps. All right, let's move on. Okay, and by the way, I'm sorry, one thing I forgot to point out. We skipped from 7 to 10. There is no 8 and 9. It says that on the test. Exclude problem 8, exclude problem 9. You actually get credit for those for free, okay? So those are free questions that you'll get credit for. So this did go from 7 to 10. Okay. All right, here's another transformation graphing. So f of x is log x, so we can write that right here, equals log of x. Okay, and we've seen that graph before. We're going to do this on Desmos. So write the equation for the g of x. Well, here's the easiest part to tell. Remember that the shifting right and left is done in the exponent. Or excuse me, in a log it's done inside of a parenthesis. So what you're going to have is something of a form here. Log of x plus a in parentheses plus b. Now those plus signs could be minus signs, okay? I'm just writing a general form. This, inside the parentheses, shifts right and left, okay? So this is the right and left. And it always shifts in the opposite direction of the sign. So if it was a plus, it would shift in the negative direction to the left. So it always fools you. That one fools you a little bit. This one, the one that goes outside the parentheses, shifts up and down, okay? So let's start with the one in the parentheses. What we're doing is we're starting with f of x right here, the lighter colored line, and we're moving over to here. So how many places is that? You're going from 0 on the x-axis to 1, 2. It's hard to read the 2 there, but that's a 2. So you've moved 2 to the right. So remember, this is the one that's backwards from what it seems. If you move 2 to the right, that's going to be a minus 2. So it's going to be log of x minus 2. Again, because you're moving to the right 2 places, it seems like it should be positive, but it's the opposite of what it seems. It's going to be negative. So that's x minus 2. Then this part of it, the plus b, is going to be going in this direction. Okay, so we've already taken care of this direction, but now we see that if we were to trace this after we've moved it over here, it would look something like this, and it would come off as a dashed line like that. Now we have to move it from here up to here. All right, now that's the one that it is what it seems like it is. If you're going up, that's going to be a positive. So we can put a plus sign there, right there. That's a plus sign. Okay? Now, how much? The only thing is how much, and it's really hard to tell. What you try to do is find a place where it goes exactly through a grid point. And so right here, it seems to go right through that grid point right there. And it also does it up here, exactly through that. So how many places is that? Remember, on this scale, every 2 boxes is equal to 1. So there's 1, 2, that's 1. 2 more boxes, that's 2. 2 more boxes is 3. 2 more boxes is 4. So here we are, we go 1, 2, that's 1. 1, 2, that's 2. And then 1 more box, so that's 2.5. So that's going to be plus, you could either call it 2.5 or 5 halves. That's equal to 2.5. Okay, so that's how you would write the equation for this. Again, it shifts 2 to the right. That's the one that goes inside the parenthesis, and it's always the opposite sign of what it seems like it should be, so it's x minus 2. And then going up is the same sign as you would expect it to be. It's a positive. So you're going up, every 2 boxes was 1, 2, and a half. So it's up 2.5 or 5 halves. Now you can do this on Desmos. So let's go ahead and do that. Actually, I can just type in the word. What the heck? Log parenthesis, and I wrote x minus 2, close the parenthesis, plus, and I'm going to do it as a fraction, 5/2. Okay? And then I should also, let me get that out of the way, and then I should also put the original function, which was simply log x. There it is. Okay, and if you look at your sheet, that's pretty much exactly what we have. So the purple one is our g of x function, and so I should write that here, g of x, and you should too, g of x equals, and that's your final answer, okay? And I verify that by looking right here at Desmos. That's exactly what it looks like. Okay, so I'm going to go on back. Okay, there we go. So that's our function. That looks exactly like what we just saw on Desmos. Okay, let's keep going. 14, evaluate. Evaluate just means find the number value of it, okay? And so it's going to be a change of base. We saw this before. So we're going to pick base 10 as our chosen base, log base 10, 36, the bigger number, over log base 10 of 3, the smaller number there. Okay, that's what you have. So I'm doing this on my calculator. So log base 10 of 36 is going to give us 1.556. And on the bottom, log base 3, log 3 is going to give us, I don't know how well you're seeing this, 0.477. Okay, and we're going to divide those. 1.556 divided by 0.477, and that gives us 3.26. Okay, and that's your answer. And the way you can check that is, what does that mean? What does this mean? It means 3 raised to what exponent will give you 36? So if I take 3 and raise it to the exponent 3.26 equals, and it gives 35.9, which is close enough with rounding, okay? It should be 36 exactly, but that's close enough, okay? All right. Okay, so that takes care of this answers video for the test review. So remember, this is an assignment. You do want to turn this in as well as the test, but I would go ahead and do this, watch this video, do this assignment along with the video, and then do the test at the same time. The problems match up. I messed up a little earlier. I did problems, I don't know. I did some of the problems out of order. So you want to just kind of watch that, but that's okay. You can just, I think I did problems 11 and 12 before I did some of the earlier problems, 7 and 10 or something. So go ahead and just watch out for that. But other than that, if you have any questions, I can answer them. I'm having tutoring on Thursday at 1 o'clock, on Friday from 9 to 10, and on Saturday I'll do tutoring from 9 to 10 in the morning as well on Saturday. This is due Saturday afternoon, and the test is due Saturday afternoon at 5 o'clock. Okay, if you have any questions, be in touch with me. Otherwise, good luck, and have a good day.